Here's sample test problem number 2. A loudspeaker is placed between two observers who are 110 meters apart along the line connecting them. If one observer records a sound level of 60 decibels and the other records a sound level of 80 decibels, what is the intensity heard by the first observer? Well, we know that the second observer is closer to the speaker because the sound level is higher. So let's try to indicate that with our diagram. Here's observer number 1. Here's observer number 2. And we have a speaker that is somewhat closer to observer number 2, putting out sound as being heard by all. And let's designate our distance here. From observer number 1, we have a distance of R1, and from observer number 2, we have a distance of R2. And we know that this total distance is 110 meters. That's given in the problem. We also know that in general, the intensity, in fact, intensity for 1 is going to be equal to 10 times the intensity level minus 120 divided by 10. So in the case of intensity number 1, this is going to be 10 to the 60 decibels minus 120 divided by 10, which is going to be 10 to the minus 6 watts per meter squared. Nice to know, and we can do the same thing with finding the intensity of observer number 2. That's going to be 10 to the beta 2 minus 120 over 10, which is going to be 10 to the 80 minus 120 over 10, which would be 10 to the minus 4 watts per meter squared. All right. We also know in general that the intensity is the power per area, and that's going to be equal to the power of the source, which is going to be the same for both observers because the power of the source is one source, over the cross-sectional area of the sphere to their location, which is going to be 4 pi r squared. So the ratio of intensity 2 to intensity 1 is going to equal the power of the source over 4 pi r2 squared over the power of the source over 4 pi r1 squared. And the powers cancel out. So does the 1 over 4 pi's. And so this is equal to r1 squared over r2 squared. So intensity 2 to intensity 1 is r1 squared over r2 squared. That's equal to, based on what we calculated earlier, 10 to the minus 4 divided by 10 to the minus 6, which is actually 100. So we take the square root of both sides. We will get that r1 divided by r2 is the square root of 100, which is 10. Or in other words, r1 is equal to 10 times r2. Nice to know. That means that since r1 plus r2 is 110, we have that 10 r2 plus r2 is 110, or in other words, 11 r2 is 110 meters. So r2 is 110 divided by 11, or 10 meters. And for that matter, R1, which is 110 minus R2, is equal to 100 meters. Alright, so that's part C. So we've answered C first. First observer is 100 meters from the loudspeaker. Okay? What is the intensity heard by the first observer? We already figured that out too. So that is part A. And the intensity heard by the second observer is part B. So there's our answer. We have the intensity for the first observer, 10 to the minus 6 watts per meter squared. The intensity for the second observer, 10 to the minus 4 watts per meter squared. And the loudspeaker is 100 meters away from the first observer. That's our answer.